All right. So the last time when we started to identify the damage for each building, we didn't have any mitigation measures. We have the hazard maps that coming from a specific return period or a specific hazard scenario. And what we did, we overlaid the hazard map with the buildings and then identify the hazard intensity and get the damage. This damage doesn't have any mitigation scenarios. So why we are doing this, why we are doing flood risk analysis is to quantify the scale of the event, how much damage that we will have, and then start to know what mitigations that we can apply in the flood plain. So this is why we are doing high resolution risk analysis, is that to know what kind of mitigation measures that best suit for my buildings. Because it has no points. Okay, we got a flooding event and this flooding event resulted in $100 million of losses, but what is next? What is next is to how much should I invest in the floodplain so that I can reduce this amount of flood losses? What the households that can do so that they can decrease the amount of losses for their buildings. So this is actually the point of doing flood risk assessment with resolution at the building level. So one of the publications that I assigned to your reading list, so if you check the Google Drive, you will find reading assignments. You will find 2 publications, both of them starting with high resolution flood risk approach. One of them is continuation to what is after risk assessment. So one of them is doing mitigation measures at the building level, and one of them is doing mitigation measures at the community level. So what do you think? Who can do mitigation measures at the building level? The owners, the business owners, the homeowners. So if you care about your building, you don't want to have damage. So you will think about what will happen in the future. What happened to the buildings in the neighborhood around you? So you will be thinking how to prepare for the next flooding event. So you will think about, okay, I need to have maybe a water pump. If I got water inside my home, so I pump it very quickly so I don't get many things damage from flooding. I get maybe some sandbags around my doors, around my windows to decrease the amount of water goes inside the building. I do like waterproofing for my building. Like some people I saw like they do flood proofing for 1 meter height. Like they maybe they build a break wall and then they proof it and they test it. And they make the building like you can have like 1 meter of water outside of your home, and there's no a drop of water inside your home. But waterproofing will need to have a waterproof doors, a waterproof windows, and a waterproof walls. So this is expensive mitigation measures. Also, there's what is called like bladder dams. So actually, if you went to Google and start searching like flood proofing, or we search like building level floodproofing and you go to images, you will find many stuff there. So not sure. Yeah, so here's kind of proofing. This is like a flood gate. So there's some stuff, maybe we need to search them specifically. So you can write, for example, Bladder dam. So this is something like this. This is called a bladder dam. It's like a balloon, but it's very thick, and you fill it with water. It blocks the water right away. There is many techniques and many mechanisms for the bladder dams. Yeah, something like this, or something like this. There's like tubes, like water tubes, like you put tube. So like it's kind of like you have a building. And if you are expecting like low amount of flood depths, so one of these tubes is enough. Is like the height is like 0.5 meter or 2 foot. But if you're expecting more than that, you need to get 2 tubes and you put 1 tube on top of them. And if you are expecting more, you need 3 tubes and you put 2 tubes and 1 tube. So this is kind of mitigation measure. And this measure is the one used in Lumberton, the city that we are doing the project for. And I'm gonna show you how it actually looks like. See, yeah, here, look at this picture. Hi. So this is actually one of, I'm sure, I believe I showed you this picture before. So this is shows the state of flooding after Hurricane Matthew in 2016. This is Walmart, like one of the Walmart buildings in this neighborhood. And it shows there is no bladder dam around Walmart and it got flooded. But during Hurricane Matthew, they get noticed that there is a flooding event. They have some time to build this bladder dam around the whole building. So if you look at this one, this is one of the tube systems. Not sure. Close the lights. Can you guys see? So much better now. Yeah, can you see? This is the tube system, not a bladder dam. This is kind of like a tube, like two tubes, and then they put one tube on top of it. So you basically hire a company. There's companies are specialized in this, and you rent this for like a couple days or 3 days or 10 days. So you come and set it up, and then after the flooding event, they take it out and they drain the water and they take it back to the company. So this is one of the things. Many facilities in Lumberton did this technique. So, and also, you know, like the water treatment plant did something similar, but they used different system. So they built like a concrete wall that connected to each other in a certain way. I just like want you to imagine that there is possible ways that are very, very fast that communities can do to protect them. So this is one of the things that we do it at the building level, like Walmart pay for this, for its mitigation, pay for that. Let's go to Google Earth and see some other places that they install this mitigation measures. Yeah, and I want to show you something that is interesting. Okay, Lumberton underpass. Mitigation during Hurricane Florence. There's some picture for this, but there's really cool. Burton, North Carolina. So this is, I believe, yeah, this is Walmart. Let me change the time and get it in like 2018. Yeah, so this is the one here at this location. And there's, I believe, like there's a water, I believe the water treatment plant did something here. They made something around like the water treatment plant itself here, if you guys see, but I believe they were taking it out. Can you see guys here? These blocks, they were connected together. And there is kind of pumping, like this is like a pipe that takes the water from here and drain it out there. And also the power substations, it has the same thing. Can you guys see? The 3 tubes, same thing. So this is kind of mitigation measures that are very fast, and it's more productive than the than having a sandbags, because sandbags is an older technique. So basically like the county having like a trucks filled of sand, and they keep dropping the sand somewhere, and they get volunteers and they drop like bags, and volunteers keep filling the sand in the bags and they put it somewhere. But these techniques is very fast. You just take from the water, whatever water is close to you, maybe even from the water that comes from the flooding, and you just fill these tubes to make a barrier around the building. But the thing is, there wasn't a way to capture what is the significance of using these systems. What is the significance of using pumps? Like you will, if you look here, you will find actually a really mega pump. This pump is like a big semi truck, like a really big one. So this pipe is really big. So it takes the water from the river and then drain it, from the city side to drain it into the river. So how can we capture the impact of flood duration? So right now the pumps decrease the flood duration from a couple days or 3 days to a few hours, maybe 12 hours, until the pump drains all the water in some places. How can we capture that? There was a stage damage function that can capture the relationship between flood depths and damage, but there wasn't a relationship that can capture the combined impact of flood depths and flood duration and damage. So you invest in having pumps, but you don't know if actually you were able to save something or not. Maybe you spent like, let's say that these pumps cost you, actually they bring like tons of them. Like there were like 10 mega bumps like this, and there were some small bumps somewhere like can you see, like we have 4 here, we have a kind of a small ones here, so there are many of them, and each one of them, if you rent them or if you are using them, this is like hundreds of thousands of dollars using these pumps. So was it really worth it? So you will have to calculate many things, not only building damage, because you need city to come back to normal, so you need the economy to keep rolling in, so you need to calculate many things so that you can know if they are good or not. Our focus right now is on building damage. So how can we quantify the impact of using a flood barrier on the total damage or the total losses at the community level, at the building level, and then we can aggregate to see how much the community loss reduction was look like. Same thing with duration. How much if the water, how much does it cost, or how much loss reduction that we are going to have if we were able to reduce the amount of flood, if we were able to reduce, the flood duration from 10 days to 6 days, or to 4 days, or 2 days, or even few hours, how much this is gonna do loss reduction. And then we can do some optimization to see if this is worth it or not. Okay, so that's what we are gonna do today. So last time we stopped at this line of code, we did what is called the flood baseline damage analysis. What is baseline damage analysis? You have a specific scenario, hit a specific community, and then you quantified how much damage that this community is going to have with this baseline scenario. What if we were able to do some kind of mitigation measures that can reduce the amount of flood losses from the baseline to maybe 50% of the baseline, or 20%, or even 10%? Okay, so this is very important because you will have to do it for your project. So what I did here, and actually you can even increase the number. So here HP is the height of the barrier. So what if we were able to use a barrier height HP1 equal to 0.2 meter? Like if like a specific household were able to build a sandbag system that is 20 centimeter, like just one sandbag around their property. What if they have more time to build, like to have 2 layers of sandbag, like 40.4 meter, or even 1 meter, or even we're able to use a flat barrier that has a height 1.5 meter? How this is gonna impact? But the thing is, you don't know if the household is gonna do this or not, and the household doesn't know how much a flood depth is gonna get. So it's completely uncertain. Like you don't know how much a flood depth that you are gonna. You might spend lots of time and money building a barrier of 0.5 meter, but you will be hit with a flood that is 1 meter. So it's worth it. Okay, so this is one thing. And the other thing, so I told there's 2 uncertainties. The first thing is the flood depths, and what is the other thing? Yeah, if they are gonna do it or not. So if they are gonna do it or not, so we need to make this uncertain. How? Like, we don't know. It depends on many things. Like, what do you guys think? What controls the household decision to build a flood barrier or to do any mitigation? What do you guys think? Do you have in mind? Like, let's imagine that you and your family live in a building and you are gonna hit with a flood, what are you gonna think about first?
On the news.
What?
Turn on the news, maybe.
To follow news?
Yeah, it's all.
Yeah, but I mean in mitigation, if you want to save like your family,
Like sandbag.
what was that?
Sandbag.
Yeah, but the thing is, will you do it or not? And the thing is, there are many uncertainties, and actually your decision will be different from a 60 years old couple live in the building. They are old, they can't do anything. So they just run, whatever, get damaged. He doesn't have the energy or the power to do anything. So it depends on your age, it depends on your level of education. Even depends even if you are young and you can do something, so like you'll say, damn it, like I will run, I have money, I can recover. So but if I got flooded or I got hit with something, so my health is much worth it, you know, like you will run. And it depends on what is your income, what is your level, what is your class. So it depends on many social and economic factors. But to propagate these uncertainties in the model, it's completely a social science research. Like you need a PhD, a social scientist to do this stuff, not you, because decisions, you need, these guys need to do surveys and survey many people to identify their decisions. And then they do some regression analysis to come up with, if this household has this age, with this income, with this race, with this ethnicity, they are gonna do this. But if they have this income and this race, they are gonna do that, right? So it's completely a social science thing. But as I looked at that from an engineering perspective, what if we make it randomly? What if we say that only 10% of the household is of the impacted buildings is going to apply this? I don't know who live there, but I will just pick it randomly and see what will happen. What if 20%? What if 30%? I believe this is the most reasonable way to do it if I want to go into deep in social science research. But if we want to do it accurately, we need to bring social scientist in the loop, and he tells us, but I need to tell him something. He needs to know who live in this house. So it's also, it's interdependent. Like you need to know the race, ethnicity, income of the population or of the household live in this building, so he can give you a decision. So you need another social scientist that he can do population allocation model that tells you who live in each housing unit within each building for all the buildings within the community. So this is one thing. Once this is solved, you provide this data to another social scientist that did do some surveys and do lots of things based on the racial makeup of the community, and tells you this, what kind of decision that each one of these social groups is going to take if they are going to be hit with a flood. Then you integrate these decisions, and once they make a decision, the decision will be, are they going to apply a flat barrier or not? Going to use a pump or not? So either one of these, and then you can integrate this in your model. But we didn't do it this way. We did it by picking 10% of the impacted population randomly, and say that these are the people, or these are the household that we are gonna apply this mitigation measure. So how can we do this? So basically you will develop a uniform random function. So you can, like, for example, say U equal rand a 1000 number. So basically we are going to develop a 1000 uniformly distributed simulation. Like you will pick numbers that are, if you plot the distribution, it will be uniform. Okay. So if you run this model, this is how we rand is a function that develops random, it picks random number out of a uniform distribution. And if we plot this, like if I plot U, so U is a vector that has 1000 number, and these 1000 number are uniformly distributed. If I plot it, it will be something like this. This is kind of a unit distribution. As much as I increase the number of samples, it will be like a complete line. Okay. So if like I want to make it the histogram, it's 100, so we'll get something like this. So this is called like a uniform distribution. So what I will do is I want to, you have the, for example, this is the community, right? This is the 20,000 building that I sent to you. What I want to do, I want to give each one of these building one random number. This random number is uniformly distributed. Okay. So they will be giving a random number from 0 to 1. And from 0 to 1. So if you pick 10% of these numbers, like that, like if you want to pick a 10% of these numbers that are randomly distributed, so you basically, so here, that's here where I did it. This is the Lumberton. I uploaded a file in the Google Drive when I told you that I need to update the, let's go to the Google Drive. This one. If you went to the course project, you will find a shape file. It's Lumberton building polygons. This one, this shape file has 20,000 building. And one of the fields in this buildings are, let me see it here. Yeah, this one, if I open this shape file, you will find a field name is R, like random number. So I generated a random number for each building. So these random numbers are from 0 to 1. If you selected, for example, let's make a query, select by attribute, and I'm trying to select buildings that has R value less than or equal 0.1. So you will find that the number of buildings selected are 2,291. So this is basically like 10% of the these buildings. Like let me make it less than, just less than 0.1. So it will be like around 2,000 building, which is 10% or around 10% of the total number of buildings. So if you pick the number that where R is less than 0.2, so this number will be like 4,600, which is around 20% of the buildings. And if you look at these buildings, you will find that are selected randomly. Like, let's zoom in here. Right. So you'll find that these buildings are selected randomly, the 20%. If you select the 0.3, so you'll find that the number of buildings are increased and they are selected randomly and they are 30% of the total building. But what I want you to do, we don't want to select them randomly from all the buildings in Lumberton. As I told you, I sent you the 20,000 building because each one has a different hazard map. And since each one of you has a different hazard map, each one has a different numbers of building exposed to flooding. So what I want to do first is to exclude the non-flooded building and only focus on the flooded buildings. It will be, if you are 500-year events, it will be around 24,000 or 25,000. So you take this 25,000 with that they have R number, and I'm not sure if they will be, if you will still need to regenerate the random number for the specific sample that you got. So you might, okay, I will tell you right now. So in your code, you need to do something. If you guys remember, this is where we stopped last time, where we calculated losses. So once you select the flooded buildings and you did some operation on these buildings, you will generate a random number with the total number of buildings. Like I only have here 2,857 buildings. So what I will do here, I will write a piece of code before I write the new shapefile that will generate 2,857 uniformly random numbers from 0 to 1. And basically they will be stored here. And then you will write this shapefile here. You will write P mapped dot U equal to, let's call it R. And this will be equal to the random number U. Does anyone of you know what did I do right now? Okay, so the R random number that I have is for the 20,000 buildings, okay? But right now I want to focus only on the flooded buildings, not the 20,000 buildings. So let's assume that you have a 500-year flood hazard map, and only 25,000 or 28,000 of these buildings will be exposed to the flooding. So what we did, we excluded all the buildings with zero flooding, and we only had the buildings that has flooded, which are the 28,000. And I give each one of these buildings a uniformly random number from 0 to 1, which is U, with the rand function. So each one has a random number. So right now you can, once you generate the new MATLAB code here for the baseline damage analysis, and you take it to GIS and you show them, you will see U, which is R, like you will see U, all the values in U vector will be stored in the shapefile in a field name called R, okay, like this one. Then right now you can, once you have them named as R, you can do the manipulation. Like you can only pick 10% of these buildings and apply a flat barrier of 0.2 or apply a flat barrier of 0.3 height or 0.5 meter height. So you can only focus on 10%. That's what I do right now. So if I want, like, for example, let's say 0.5, and I said apply. So right now I have from the 20,000 building around like 12,000 buildings, which is almost 50% of the buildings. And I'm gonna use this 12,000 buildings and apply a flood barrier height of 1 meter. However, the other 50% of the building doesn't have a flood barrier. So what I did, I picked the buildings randomly and I only picked 50% and see how much a flood loss reduction the overall community if 50% of the household were able to apply mitigation measure. Does any one of you have any question? Is it confusing at all? Okay. All right. So here, let's come back here. So what I did here, I just added a piece of code that give each one of the buildings, and I make the number is based on the total number of buildings. I have 28,000, so I put 28,000, and I wrote this in the shapefile of the building damage. All right, so right now I didn't do any mitigation analysis. So let's start the mitigation analysis. So I defined 5 barrier heights that I'm gonna investigate. You can define your own barrier heights. You can actually, I find it trivial if you go from 0.2 to 0.4. I feel like the least that you can go with barrier height is 0.5 meter and maybe 0.75, 1, 1.25, 1.5 meter. That will be very reasonable to do. So if I were you, I would change this and start from 0.5 to 1.5 or 1.75. And also I investigated a number of duration. So what if we were able to reduce the duration to 1 day, 2 days, 6 days, up to 10 days? And I put these numbers because if you guys remember, I told you that I had the duration from 0 to 300 is divided into from step number 1 to step number 100. So 100 value. So each one or maybe 50, depends on what is your code is written. So each one will represent 3 hours. Okay, or this is if you are from 0 to 100, but if you are from 0 to 50, you divide 300 over 50. So each one step will represent 6 hours. So that's why I put the duration number 1 is 9, because 9 represent 1 day, like the step number. Like if we go to duration here, or I have lots of input here. Okay, yeah, so if I went to the duration, you will find that the duration number 9 is 24 hours. Step number 9, can you see? Step number 9 is 24 hours. The line number 17 is 48 hours. line number 49 is 145 hours, which is like 60 days. Right? So this is what these numbers means. Yeah, you will say, okay, it's 1 day. Why did I put 9? 9 because line number 9 or row number 9 has 24 hours. Because this is how I built the 3D fragility. And the next step is to do mitigation analysis for only the randomly selected 10% or 20% or 50% of the building that you choose to apply the mitigation measures. So you will do a extra step in ArcGIS. You will basically, as I told you, you will only include the flooded buildings. You exclude the non-flooded buildings. For example, there will be 28,000 building. And then you will use the field R, this R, let's deselect anything, this field, and you will do a select by attribute, and you will select R less than 0.1. And you will say apply, and then you export these buildings. File, export data, but actually it's like to be consistent, let me do it for only the flooded buildings. Yeah, all right. So I don't want to do it for all the buildings so that I don't want to confuse you when you read this video, because you will find that some buildings outside the floodplain. So let me deselect all of this. And this file has the 2,857 flooded building. So if I select all these buildings, like if I said Control All, and let me show this shapefile. Let me unselect this. Okay, so let me remove these selections. So right now I can't see this building. So what should I do if I like I'm checking this box and the building doesn't show up? Does anyone of you know why? So what I will do zoom to the layer and see where are these buildings at. Actually, this buildings is out of the earth. So they are projected in different projection. So you can see like there's no base. So what should I do? You need to project them back to the earth, to the system. So what I do is I go to Arc Toolbox, and you will find projections and transformation toolbox, and you project them to the same projection of the data that you have. So let's go back here. You will find data management tools, projections and transformation. You will do something is called define projection. And you will put this data here. And you will define the projection. Actually, my projection in North Carolina is NAD 1983 State Plain, North Carolina. So once I say okay, it will take like a second, and these buildings will go back where they have to be. Like if I zoom back, zoom to the layer. So they will get back here. Can you see? This is how we fix it. All right. So actually, this is what I'm trying to say. Like I'm only selected the buildings that are flooded. So if I put the flood depth hazard map, you will find that all these buildings are within the floodplain. So that's what I'm trying to say. Don't do all the analysis for all the buildings. Just select the buildings that are flooded and do the mitigation analysis for only these buildings, because you don't want to select buildings that hasn't been flooded or outside the floodplain and apply mitigate flood barrier and bumps, and they don't need it. Okay. All right, so here I'm only focusing on these buildings. So let's deselect them. So once you define what I told you here and you built this attribute R, you will find R here. So basically, if you select by attribute and you select buildings that have R less than or equal 0.1, so you will find that you have 285 out of 2,000, out of 2,857. So it's almost 10% of the buildings, and they are selected randomly in the floodplain. So if I zoom in here, you will find that the buildings are randomly selected. So uniform distribution helped us to select random buildings in the floodplain, and that's the job that we need. Okay, so I'm done with this. And then what I'm gonna do right now, I'm gonna read so right now I want to isolate this 10% of the building. So what you are gonna do, you are gonna click on this and say data, export data, and you export this 10% of the building. So and we are gonna only run analysis or run mitigation analysis for only 10% of the building. And once you are done, maybe you name it like Lumberton buildings. Like what I will do, I will say Lumberton buildings, and then I will say 10, so that this folder, I know that these are 10% of the building. And then I will say okay and export the file. And next step is to reselect. Sorry, I do the same thing, but I only select, for example, 0.2% of the buildings. And I will say apply. So I will have 592, and I export these buildings and do the 50, the like 10, 20, 30, or you can go by 20, 40, 60, 80, and the 100%. The 100% is the original shapefile, but you can go 4 steps. Sorry, you can go 5 steps or 10 steps, like 0, 10, 20, or you can go 0, 20. The 0 is like no building is applying mitigation measure, and this is the baseline loss analysis, like without any mitigation. And then 20 is just 20% of the building applying these mitigation measures. So you will end up having, for example, 10 shapefile. Each shapefile has a randomly selected percentage of the flooded buildings. And I'm gonna do right now some mitigation analysis in MATLAB on just the 10% selected. So right now I'm naming a vector, it's S10, and I'm reading the shapefile flooded buildings point 10, which means that this is only 10% of the flooded buildings. And I'm doing the same thing. I read the attributes that I use for loss analysis. Do you know what is the important attributes when we do loss analysis? Do you guys remember? The attributes that we need is the archetype, the water surface elevation, or the flood depths measured from FFE and the flood depths measured from the ground elevation, various floor elevation and ground elevation, and also the building value, since we are calculating losses, because we need to convert damage to losses. So these are the 4 important things. And we will do the same thing here. We read these 4 parameters from the shapefile, and then I run damage analysis with mitigation. Let's see how I formulated the mitigation analysis. Since I have first thing I will do is investigate the impact of the barrier height on the amount of flood loss reduction. So the first thing is I defined how much losses each building will have within this 10% if I don't apply any barrier, which is the base flood loss. If I have a barrier height HB1, which is 0.2 meter, if barrier height 2, which is 0.4 meter, 0.5, 0.6, 0.8, and 1 meter. So H1, H2, H3, H4, H5 is these. And this will be a vector for each barrier with for each one of the building, and has how much each building will have in losses. So for example, this will be like one vector, and this is like for HP barrier height equal 0.2 meter, which HP1, and this is the loss for each building, like building number 1, 2, 3, 4, 5. So that's what I defined over there, here, this one. But this is for flood barrier number 1, and I do it for flood barrier number 2, 3, and 5. Okay, so this is the total loss for each building, right? But what I'm interested in, what is the loss reduction for each building, right? So I have this building has 100K in losses, but when I applied this barrier height, it has 70K in losses. So what I'm interested in is the flood loss reduction. So I defined same thing, but I said loss R HB1. What is the loss reduction? Which will be the loss from the base scenario minus the loss from HB1. If we are looking at barrier with height HB1, which is 0.2 meter, okay? But this will be like a vector like this for each building. But I want to aggregate this at the community level. I want to sum how much loss reduction for the entire community. What should I do? I sum all the loss reduction for all the buildings. So I come after this and take the summation, but this should be loss reduction. The second one. So I defined another vector that is called loss reduction total for the total building. And it is not vector anymore. It's only one single number, right? Because this will be a vector, and the size of this vector is the number of the buildings for each group of buildings, like for the 10%, 20%. But this one is just single number. And all of these, I'm just making some definition. I'm like defining that there's a matrix that I'm gonna put some result, store some result in, and just put zeros right now, and I'm gonna fill them later. So that's what I did here. I just prepared the matrices. Then I start the analysis. So let's see what is the body of this analysis. So I'm making a for loop starting by building number 1 until all the buildings stored like in building S10, which is the buildings, the 10% of the buildings. And then I made an if statement saying that if the building has archetype 1 and 3, do some stuff. But if it has different archetype, do other stuff. Do you guys remember why? Because yeah, archetype 1 and 3 has a crawl space foundations. They have the flood depths measured from the ground elevation, but all the other buildings has the flood depths measured from the first floor elevation. Okay, so and then what I did for building for archetype 1 and 3, calculate the loss based on the fragility, loss FR base, that means like without any mitigation, like without any barrier. And this losses will be calculated such that in plate from the 3D loss surface. Do you guys remember the 3D loss surface that we have for each building archetype? Like this one. Yeah, like this one. I want to interpolate from this surface. But the thing is, I didn't include the duration yet. So why did I pick the surface? Why I didn't use the 2D? You can use either. But what I did, I picked the surface and I only asked in MATLAB to take the maximum, like at 10 days. Like at the maximum, because at 10 days, the 3D surface will generate a loss curve that is matches what is the 2D function has. So do you guys have any problem? Do you have any question? No. Okay. All right. So I have like here at 10 days. So what I did, I take the surface as a base and I ask MATLAB to go at day number 10, which like the same loss, like if I cut this section here, this loss curve, if you put it with the 2D loss curve, they will match with each other. As I showed you, I believe like from one of the publications, here. Yeah, this one. Can you see? This is the 2D loss function. Can you see at day number 10, they are almost the same. So if you cut here, you will find that the loss curve will match all the values on the 3D curve. But if you interpolate at day number like 1, no, they will not match because here the losses is less than at day number 10. So what I did in the MATLAB code, I did 1D interpolation. So how did I do 1D interpolation from a 3D function? It's a 3D. I should do 2D interpolation, like at specific flood depths and a specific flood duration. But I did 1D because I make the duration constant. I ask in MATLAB, don't search duration. I pick duration at 10 days and just search in the flood depths with the flood depths. So that's what I did here. I picked the depths. So I give it the 2D function. So like I give these values and I only picked the 3D loss surface at duration D5. And if you guys check back, you will find that D5 is the 10 days duration. So basically I ask MATLAB cut section at the 3D surface at day number 10 and use this as a 2D curve. So I converted the 3D into 2D curve in terms of interpolation. All right, so here and then interpolate at the flood depths measured from the ground elevation. Once you do that, you will get the flood loss as a percentage of the building market value. So it will tell you that the flood loss for this building is 20%. Then I ask MATLAB, multiply this loss percentage by the building value here. So I gave it the building value. I have a building value for each building stored in this vector. Like if you go here, you will find the building value for each building. So for building number I, multiply by this building value, $485,000. Multiply by this number and divide by 100 because I believe the numbers that you will have from the 3D surface, it is not, if you guys remember, it is not like 0.98 or it is 9.99, it's 99 or 89 or 59. So we need to divide them up by 100 so that they can be ratio out of 1 and then multiply by the building replacement cost. Okay, so I did the loss for the base and then I run the mitigation analysis. So right now I run base flood loss analysis without any mitigation measure. The next step is I did an if statement saying, what is the flood depth measured from the ground elevation for building number I? And if it's less than the barrier height number 1, so the flood loss will be 0. What does it mean? I put a barrier height 20 centimeter. I'm asking MATLAB, it check the flood depths. Is it less than 20 centimeter? It's less than 20 centimeter, but loss equal to 0. If it's more than 20 centimeter, calculate the flood loss. So you didn't do it. So it's either you save the building and you have 0 losses, or you will go back to the original loss. Okay, so that's what I did here. It's either put 0 if the flood depth less than the barrier height, or calculate the flood depths, calculate the flood loss as like there is no any flood barrier. And then end the statement, then right now I was able to know if I have flood loss reduction or not. So what I will do next, calculate the flood loss reduction for this building. How? Subtract the losses if you use the barrier from losses without barrier, and then you will come up with a number for this building. And then once you come up with this number for this building, put it in the loss total. Okay, and then rerun this code and get like the next building and the next building. So let's assume that we got to the next building and we did the same thing. You will calculate the flood loss reduction, and then you keep storing it in the loss reduction total for the entire community. Like once you get this, start with this loss total 0. Once you are done with building 1, put it in here. Once you're done with building 2, put it, sum it on the original value stored in this cell, and you keep repeating this.
What is the statement, Dr. Else?
What
Is the statement, Dr. Else?
this one?
Yeah.
So this is the loss based on the fragility for each barrier number 1 for the 10% of the building selected, and you interpolate from the 3D surface. Like it's the same like this one.
But I interpolate with what?
You interpolate from the 3D loss surface. It's the same surface.
With the depth, the full depth.
With the full depth, like there is no any barrier, because it's something like this. Yeah, like this one. So if the building, if the flood depth is like 0.5 meter, so the flood depth is the flood loss is 0. But if the flood depth is 1 or 1.5, you will go back to the original function. You will not use a function because
Imagine it would be like shifted downwards. Well,
What do you mean?
like
Look.
I will subtract maybe, I don't know.
This is, we discussed this last time, like if you have a building. You have a building here. And you build a barrier here, okay? You don't have any problem. If the water is here, right?
Yeah.
The loss will be zero. But once the water get here, what you want to say, how about if I only take this and no, it doesn't work this way. All the water will spill and make one surface. Because this is the special thing about water. The water always want to find the lower ground. So it will go here, fill here, and keep moving until it makes one surface. And we talk about the like the things that you like. This is not perfect, but this is makes sense. I mean, like, because right now, once you like put a flood barrier, so you are pushing the water to go somewhere else. So the flood depths will getting increased because you are clearing spaces. But this will be like, makes sense if all the community is making flood barrier, like all the building is making a barrier. So the water has nowhere to go, so it will keep going up until make one surface. But here, for like specific, like a small number of buildings are doing this, and this is just only the flooded building, not the 20,000 building. We are talking about 2,500 buildings got flooded, and we are select 10% of them, which is 200 buildings, applying this mitigation measure. Okay, so once the water is going up, so it just the water will come from the lowlands to spill here. So we are using the whole flood depths. But if you want to know exactly how much of flood depths that this building is gonna get, you will have to do this in hectares to build it and see what exactly the depths, what exactly the duration, what's everything. You will get it exactly. And then you will know, is it worth it? Our assumption is right or not. This is also can be a good point of research. Okay. Do you know, like, if you want to do it in hectares, how can you do it? Like, we can think like
Can add a polygon in
this is to model the building. How about the barrier?
I can add also a polygon around the building and give it the elevation of the barrier.
Yeah, but yeah, so you can do two things actually. You can draw this barrier in hectares itself. There's an option is called weir or something, so you can build it as a weir and you can give it a height. This is what we do if you have a levee. So if you have a levee, if you want to do levee enhancement, you draw a line and give this line a height. So if the water exceeded this height, so this is one thing to do it. But if you will do it for many buildings, so it will be takes a lots of time. But even in ArcGIS, if you want to draw a polygon around the building, you will have to do it building by building. And then once you do it, you will have to give it an elevation, and then you will have to burn it in the digital elevation map. So you will have to convert the polygons from a feature file or from a shape file to a raster file, and then combine it with the digital elevation map, and then take it to hectares and run a new train and do the whole thing again. But it's worth it if you want to know how much impact this is going to get. It's really interesting point. All right, but also this is still contingent on that you are using resolution of the mesh that can capture. There is something that you did here. Let's say that your mesh is big and all the things that you did is within the mesh. So there is no nodes that can capture this variation in the elevation. So it doesn't make sense, all this effort. So I believe if you want to do it, you will have to minimize your area, like only get 100 building or something and make your mesh like 1 meter or 0.5 meter and see what are you gonna get. All right.
Would you be able to, I guess, like maybe elevate the building maybe by the barrier height?
This is an interesting point, but
Capture
we will have a mitigation measure that investigate the impact of increasing the building elevation, but building elevation is completely a different mitigation technique, because we are talking about techniques that you can do it right away when you have a flood. But if you know a flood is coming, you cannot like get a contractor and elevate.
Just to capture the effect of the barrier, since we assume that no damage is up to the barrier height, if maybe we were to say that the building was maybe like 1 meter higher or whatever the barrier height is, just for
I believe you can do that. It will give you almost the same thing. It's also a good idea. Like, but the thing is, you will need to So basically, yeah, that's really good point. So what you will do is you will create a new ground elevation or a new vertical floor elevation, and just a +1 for all. I'm not sure if you can +1 or not, because this is also an interesting point. The thing is, when you build a flat barrier, you build a flat, this is one of the points we addressed it in another paper. The thing is, when you build a barrier, you build a barrier from the ground elevation, not from the vertical floor elevation. So the thing is, if this is the vertical elevation, and you build your barrier here, this barrier is not gonna do anything, because you're already, your vertical elevation is here, so you still have 0. So your barrier to be meaningful, it should be like something here above the vertical elevation, so that it can retain some water before it gets into your house. So barriers, if you want to do this, you want to increase the ground elevation by 1 meter, or whatever the barrier height is gonna do for each building. So just like kind of you manipulate the shape. Fine, but it's a good point. But make sure it's from the ground elevation. All right, so okay, let's get back here. All right, and I did the same thing. Once I end this statement and calculate the loss for the 10%, I did it, I did it for barrier height 1, I do it for barrier height 2, and I do the same thing for barrier height 3, 4, and 5. Same thing, but I just changed the barrier height. And be careful about the naming so that you can recognize that you are calculating losses coming from barrier number 3 for buildings, the S10, which represent 10% of the buildings. Okay, once I'm done with this, I end up with having the ending this F statement, and I'm starting another F. So this is F buildings are 10. Yeah, I'm saying else, like I'm saying if the building is archetype 1 and 3, else any other thing, do the same thing, but calculate the flood depths measured from the vertical floor elevation. Okay, so I'm doing the same thing, but for the other archetype, and measure the flood depths from the vertical floor elevation. And once I'm done, I'm ending this step and only capture the loss reduction total for all the buildings, because that is what I'm interested in, how much loss reduction at the community level I have. And once I'm done with this, you can repeat the same thing for 20% of the building. How? If you have everything automated, I copy this. Until, yeah, I copy all this code, Control C, and I open another MATLAB code. So it's about like 126 lines. I don't want to rewrite these lines again to do the same thing, but for 20% of the building. So what should I do? To do the same thing for 20% of the building. Exactly. So I have S10. I copy S10, Control C, Control Find, S10, and I change it with S20. So basically, I have another shape file that has 20% of the building. I rename everything the same name, but just it changing from 10% to 20%, and then say, okay, replace all. So once I replace all, look, I made another shape file name S20, and I'm reading the other shape file. That's why I'm telling you, do the shapefile thing first, like go here and export 20% and name the folders the same name, like flooded buildings 10, flooded buildings 20, flooded building 30, and put them in the same MATLAB folder. And once we do this trick, and just to change the 20, so it will read 20, it has the same attribute names, and I'm making another columns or another matrix that has the S20 numbers, and run the whole thing again. So what I did exactly, rather than applying the mitigation measure on 200 buildings, I'm applying the same code to another shapefile that has 400 buildings. And I do the same thing with the 30, 40, 50. So one of you will say, why you are keep repeating things. However, you can do a for loop. Like you will say, okay, since there is something is repetitive and you can repeat it, why you don't do a for loop from 1 to 10 and keep running the shape files that you have? And loop number 1 will use file 10, but the thing is the size of the shape files is different. Like each one of the loops have different numbers of buildings. So that makes it a little bit complicated. So I found it easier. There's a way you can do it, but it just need more thinking and more coding. But I found it a much easier for me to copy the code, change the name of the folder, and paste it back. Copy the code, change, like what I do next. So I take this Control A, Control C, and I get back to my other code and paste it here. Can you see? It is the same one. S20, S20, all of them is the same code, but with S20. And then once I'm done, I go back here and I say Control Find S20 and replace it with S30. And then I replace all. And then paste it back. And I do it for all the 10 groups of building, 10%, 20% until 100%. So if you look, like each one is 125 lines and we have 10. So if you multiply them, it will end up with more 1,000 lines of coding, and you just finish them and like you only put some effort in the very started lines, but the other 900 you just changed names. Okay, let's get back until, so this is S40, 50, 70, 80, 90, and this is the 100. If all the buildings are applying these mitigation measures. Does anyone of you have any problem with applying mitigation measures, flood barrier? Is it easy? I believe it's easy. If there is a flood barrier, so and the barrier height is less than the flood depth height, flood loss is 0. But the flood barrier is less than the flood height, so there's amount of damage, and you will use the original function. It's as easy as that.
Instead of using the ground level, we want to use the level of the barrier to see the flood that, like, how much impact it have, right?
Yeah, so I have the barrier height measured from the ground, like 0.2 meter, and I have the flood depth measured from the ground, 0.4 meter. So 0.4 is more than 0.2, like, and then you neglect the barrier, like there was no barrier, and
It's
deal it
0.4,
with, yeah,
that's
it will
But
be
if it's
0.4.
less, then you put 0.
0, yeah, because the water will not make it there.
Just as if you obtain a negative flooding where you have to put 0, it's the same thing.
Yeah, exactly like negative flooding. All right, so okay, so I'm escaping this part because this part I added to the code because a reviewer need to calculate something. So I did it here. So I'm gonna escape this part. It's not needed. And what I'm gonna do, yeah, I'm gonna move to using pumps. So I'm gonna give a hint because we only have 5 minutes, but I'm gonna give you a hint. We did the same thing, like what we did was the flood barriers. So what I did here, I created a vector that has losses for flood duration D1, which represent 1 day, for S10, 10% of the building. And I did another one for 2 days, and I believe 4, 6, and 10 days, D1, 2, 3, 4, 5. And then I created another vector that has loss R. What is loss R? Is the loss reduction. So I calculated total loss. If you are deploying a water pump to decrease the flood duration to 1 day, how much losses do you have? So I'm not saying how much loss reduction. So this will calculate how much new losses that you will have. And to know the flood loss reduction, you subtract the loss with mitigation from the loss without mitigation. So that's what this vector will have. And then I calculate the loss total for all the buildings that applied this mitigation measure. So I did the same thing, but here, what I did, I made a for loop, and if buildings are archetype 1 and 3, use something, and if it's other than that, else. So you'll find here ground elevation, else use FFE. So let's see what interpolation that we have here. So I did linear interpolation from the 3D surface. So this is the X values in the surface. And I used the values on the 3D surface at duration D equal 1. So I did 1D interpolation, not 2D interpolation. Why? Because I have the duration constant. Like I'm saying that the flood depth, that the flood duration will stay only for 1 day. Okay, so I make all the duration constant for all the buildings, like decreasing the flood duration from 10 days to 1 day and interpolate at this 1 day, like this one. Rather than the first one that we calculate the flood losses that comes from this curve. Right now, how about if the building has this loss curve? Can you see the difference? This loss curve never reach 100%. But this one reach 100%. This one, the maximum it reaches like 55%. So buildings with 1 day flood duration cannot reach 100% loss. So there is a huge amount of loss reduction. So that's what I'm doing right now. I'm asking MATLAB using the flood depths and the values on the 1D duration and do 1D interpolation and get how much flood loss that the building is gonna accumulate. So here it is. Like interpolate with F3D loss and use only the flood duration that is equal to D1 and use flood depths measured from the ground elevation and then multiply, once you get the loss ratio, multiply by the building value over 100 so that we can convert the loss from 0.5% or 0.2% to dollars, like multiply by 500K, which is the value of the building. Then I do the same thing with here. So can you see I did it for D1, D2, same thing, D3, D4, D5. It check for flood duration. If you guys remember, D1 is the 1 day, 2 days, 4 days, 6 days, and 8 days. So I'm doing all of them in the same loop. And then I said else, if the buildings are not archetype 1 and 3, do the same thing, but just to change it from ground elevation to VersaFloor elevation. And then multiply by the building value over 100. And then I said end, and then I calculated how much loss reduction for each building and what is the total loss reduction. So can you see this is a vector and has a number at each row, and each row has a variable I. So for building I, do this for building 2, 3, 4, 5. Once you are done with all of these, take the summation and put all of them here. This will be a one single number. And once I'm done with all of that, I take all the loss reduction total and get them out here. This one. So what here, these are single numbers, right? Like this is loss reduction total for all the buildings, for all the 10% of the building due to D1. So I create a vector that can have all these 5 mitigation scenario in one vector. Like if you use D1, D2, D3, D4, D5, put them in one vector. So I put all the mitigation that comes from duration here in one vector. So if you want to look at them here, let's see loss. Loss reduction. Okay. So you can have them this is the loss reduction for each building that has a flood barrier, that has flood duration D1. Okay. But what I'm looking for is loss reduction total, not. So find here loss reduction total. So this is an example of the loss reduction total. One number, it will be a really big number, like a million, like $4 million in savings. And what I did here, I put them in all of them in one vector. So you can search this, you will find a vector that has 5 by 1 and has all the loss reduction coming from D5, D4, D3, D2, D1. So right now I'm done with the loss reduction that comes from duration and also the loss reduction that coming from using a flat barrier. It's a very simple, it's repetitive, and you can do it very quickly. I recommend you to start doing this so that you can hit on the middle, like you still know everything, so you can do it right away. If you have any questions, send me a message. You can do the same coding that I did, and it will be very smooth. Okay. All right, sounds good. See you guys next time.